Example 1, for f of x equals x plus 1 over x squared minus 4, determine any vertical and horizontal asymptotes and intercepts, then graph the function and state its domain. The first thing we want to do is factor the top and the bottom. Well, the top doesn't need factored, but the bottom does. It factors into x minus 2x plus 2. Let's talk about vertical asymptotes. A vertical asymptote is where the x value makes the denominator 0. So we have vertical asymptotes at x equals plus or minus 2. So 2 makes the denominator 0 here, negative 2 makes the denominator 0 there. So we have two vertical asymptotes. So let's draw in the one at 2 and the vertical asymptote at negative 2. What about horizontal asymptotes? Well, that's a comparison of the leading terms. That's your ending behavior. So this reduces the f of x on the ends as x approaches infinity, reduces to 1 over x. So that means we have a horizontal asymptote at y equals 0. So we'll put in y equals 0 as an asymptote. X-intercepts, to find x-intercepts, we plug 0 in for y. So if we had 0 equals x plus 1 over x squared minus 4, to make a fraction equal to 0, we have to make the top equal to 0. So we have an x-intercept at negative 1, 0. So negative 1, 0, we have an x-intercept. For the y-intercept, we plug 0 in for x. So if we plug zeros in for x up here, we get negative 1/4. So we have 0, negative 1/4. So negative 1/4 down there. We'll talk about the domain once we get this thing graphed. Well, we have 1, 2, 3 regions where we have to graph. And we have a couple points in here that we can, I'm pretty confident the graph does this because I don't have any other x-intercepts. So it didn't dip down here and come back up because we'd have another x-intercept sitting there. So I'm pretty confident that's what happens in the middle, but what about the other regions? We have no other points to go off of, so now we need to get some points. How about we plug in negative 3? That would be in region 1. Now we're going to plug negative 3 into, up here would be nice, negative 3 plus 1 over, we get negative 5 times negative 1. That'd be negative 2 over 5, so negative 2/5. This graph is down here at negative 2/5 right here. So I'm pretty confident that the graph does this action in region number 1 or way off to the left. What about some points off to the right-hand side, like 1, 2, 3? What about plugging 3 in? And I'll plug 3 into the factored form. That's usually the easiest. We have 4 over, now I'm plugging 3 in, 1 times 5. So we have 4/5. So we have 3 4/5. Now the graph is going to follow, it's going to hug these asymptotes right here. Now let's talk about the domain. The domain is from negative infinity. Now this is the x values. Negative infinity to negative 2, negative 2 to 2, and then 2 to infinity. And here's a nice look at it with a graphing utility. And this is what it should look like. And if you go back to my drawing, it looks very similar. Example 2, for f of x equals x squared minus 4 over 5 times x squared minus 5, determine any vertical and horizontal asymptotes. Same instructions. Well, we want to factor the top and factor the bottom. So over here, we have the top and the bottom factored. Vertical asymptotes, that's what makes the denominator 0. So in this case, we have plus and minus 1. So we have a vertical asymptote at 1 and a vertical asymptote at negative 1. Horizontal asymptotes, that's a comparison of the powers, the leading terms that is. So since these are the same, this graph is leveling out at 1/5. So 1/5 is very close to the x-axis. We'll draw it right there. X-intercepts. To find x-intercepts, you plug 0 in for y. So we have 0 equals x plus 2, x minus 2 over, this doesn't matter really for the finding x-intercepts, but because we want to know, well, what makes the top 0? That's how you make a fraction 0. It's the top. So we have x-intercepts at plus or minus 2, 0. So we have, we're crossing the x-axis here at 2 and here at negative 2. Now for y-intercepts, we plug zeros in for the x's. So we have 4/5. So 0, 4/5. So that's right above here, right there. Now we don't have any x-intercepts in the middle of the graph, so pretty confident the graph does this. If it went down below, we'd have some x-intercepts down there, or if it crossed. The domain is from -infinity to -1, and then union with -1 to 1, and then we have 1 to infinity, but we haven't finished the graph. Since I have these x-intercepts, I'm pretty confident that in region 1 it does this, and in region, let's say 3, or off to the right here, it's going to hug those asymptotes like that. Let's look at the nice graphing utility picture we have, and that's exactly what happens right there. Example 3, for this function, we're going to go through the entire process again. Vertical asymptotes, that's what makes the denominator 0. So we have x equals -2. So we have a vertical asymptote at x equals -2. Horizontal asymptotes, that's a comparison of the leading terms. So this one is shooting off to infinity, so none. We don't have any horizontal asymptotes, but what we do have is a slant asymptote. In order to find the slant asymptote, we do long division. So what do we multiply times x to get x squared? We multiply times x. We have x squared plus 2x. We subtract, so we have -3x minus 2, and then we multiply by -3. The remainder doesn't matter. We ignore the remainder, but it is a remainder of 4. So now the slant asymptote is y equals x minus 3. We have a y-intercept of -3, and then a slope of 1. So here we have our slant asymptote. The x-intercepts, that's what makes y equal to 0. We can factor this top into x minus 2 and x plus 1. So our x-intercepts are 2, 0, and -1, 0. So 2, 0, -1, 0, right there. Our y-intercept, we plug 0 in for all of the x's. So we get 0, -1 for a y-intercept. Now we have a pretty good idea of what this graph does over here. We're going to hug those asymptotes. Now that takes care of the right side of the vertical asymptote, but what about the left side? So we're going to have to plug in one value. How about -3 right there? Let's plug in -3, and we can plug this into the factored form. So we have on top we have -5 times -2, and in the denominator, when we plug -3 in, we got -1. So that's going to be -10. So our little extra point is -3, -10 down here, and something like that right there. Our domain is -infinity to -2, union with -2 to infinity. Here's our nice graphing utility diagram. Example 4, determine any vertical and horizontal. We're going to go through the same process. Here we have the factored form of our given equation. And notice that the x minus 3's cancel out. When that happens, we have a hole in the graph. We have a hole in the graph at 3 comma something. Now, I know it's 3 because 3 makes the factor that canceled 0. So put 3 in here, you get 0. Now to get the y value, you plug that in to what remains. So we're going to plug that into the factors that are still alive here. X plus 3 over x plus 2. Now if we plug 3 into that, we get 6/5. So 1 1/5. 6/5. Now we're going to plot that hole. So we have 3, 1 1/5. So 1, 2, 3, 1 1/5. That's about right there. The first thing you need to do when you work these is factor it all out and check to see if any of the factors cancel. Now we're going to do all the rest of the information with what is left over, with that right there. Vertical asymptote, that's what makes the denominator 0. So we have x equals -2. So x equals -2 right there. Horizontal asymptotes, that's a comparison of the powers. So they're the same. So we have a horizontal asymptote at y equals 1. So that hole is just above the horizontal asymptote. X-intercepts, that's what makes the top 0, so negative 3, 0. 1, 2, 3, 0. A y-intercept, that's what you plug zeros in for the x's. So we get 9, 6, or 3 halves. So 0, 3 halves. So 0, 1 1/2, about right there. And now I pretty much have what the graph should look like. Like that, hug asymptotes there, hug asymptotes there. And the domain is from negative infinity to negative 2, union with 2, negative 2, to infinity. And there's a nice representation of it. A lot of the graphing utilities that we use don't do a very good job of showing holes, but we have a hole at 1, 2, 3, and that was 6/5 right there.